Hello, ladies and gentlemen. Today we're going to be talking about the distance formula, the midpoint formula, and how to tell if lines are parallel or perpendicular. So it's going to be our goal today. So basically, as do now, what I would ask people is, hey, can you figure out how far apart these points are? And I have students go ahead and try to do that. Well, when they're on the line like this, it's pretty easy to tell, right? We just count the boxes. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so they're about 8 away from each other. That's fine. Where that starts to get a little bit harder is when they're diagonal from each other like this. If I wanted to count how far apart they are, well, I can try to count the boxes, but you can see they don't necessarily line up perfectly on the boxes. Well, maybe it's 1, 2, 3, 4, 5, 6, 7. That's if I kind of go at an angle to them. Okay, and if I go across, it looks like it might be around 4 or 3. But again, it's really hard to tell exactly what that number is that I'm looking for. So we need a better way to kind of figure out that distance. And the way we're going to do that is by using the distance formula. Now, you've probably heard of the distance formula before, okay? You probably actually learned it last year. The problem is that nobody ever remembers the distance formula. And the reason is because it's got a lot of variables and a lot of everything's going on, and it's not the most beautiful looking thing to remember. Here's the thing, though. I'm going to teach you guys a trick. It's actually something you already know. When I go to find the distance between two things, the distance formula really is just Pythagorean's theorem. Okay, it's really just the Pythagorean theorem. And I'm going to apologize for my handwriting as I do this. Especially H's are hard. Okay, but the Pythagorean theorem, there we go. Okay, that's really all we're going to be using for our distance formula, okay, is the Pythagorean theorem. Now, if you remember that from last year, when you took geometry, a squared plus b squared equals c squared, or the leg squared plus the leg squared equals the hypotenuse squared, all right? We're going to be using that same formula in order to find the distance. If you go back and kind of look at our previous slide here, if I want to find this distance, I can actually kind of draw a right triangle by kind of connecting these spots right here. Oh, and I can kind of see how far apart that is. I can kind of see this right triangle, and I can then use Pythagorean's theorem. All right? And through the magic of video, we now have our distance formula. The distance formula is the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Now, looking at that again, distance formula you heard, it sounds really complicated, but what it really is Pythagorean's theorem, okay? So if you remember, Pythagorean's theorem is a squared plus b squared equals c squared. And what we can do is, if you think about it, the hypotenuse, or this distance, is really this c. The a is the distance between the x's, and the b is the difference between the y's. And you'll see this in a moment when we go to do the next one, okay? So if we go back and look at my example, the distance from here to here would be your b, and the distance from here to here would be your a, or in this case, 3 and 4. So I can simplify this by square rooting both sides and then say, all right, that distance, which is my hypotenuse c, is the square root of a squared plus b squared, which is exactly basically what this formula is telling us down there. The a and the b are how far apart your x coordinates are and how far apart your y coordinates are. All right, Mr. Guy, well, you showed us that, but how does that help us? Well, visually, the one way we can do it is by the way I just said. We can go ahead and we can look at this and say, all right, how far apart in the x and y are these 2 points? Well, it looks like in the y they're 4 apart, and the x they're 3 apart, and I'm trying to find this distance, or the hypotenuse. So I'm going to be doing 3 squared plus 4 squared, and I'm going to be square rooting that in order to get my distance. And again, I could set this up like 3 squared plus 4 squared equals d, or distance squared, and I could go ahead and solve just like I would use Pythagorean's theorem. It's just kind of a slight modification on it. 3 squared is going to be 9. 4 squared is going to be 16. So I'm going to have the square root of 9 plus 16 equals my distance, which 9 plus 16 is 25. So the square root of 25 is equal to my distance. And we know that 25 is a perfect square, and it equals 5. The distance is 5. And we don't have any units, just 5 units or 5, whatever. All right. Okay, here's what I want you guys to do. I want you to go ahead and try that on your own. I'm going to pause the video. You guys go ahead and try to find the distance between these 2 points, and then meet back and we'll check our work together. All right, ladies and gentlemen, we should be back again. Let's go ahead and let's check our work. So I got about 8.6 as my distance, or the square root of 74. Again, you should have had a 5 in the x and a 7 in the y. 5 squared plus 7 squared, or 25 plus 49, which equals the square root of 74. Now, I'm actually okay with you leaving it like this as your answer. This is the exact answer. That distance is exactly the square root of 74 apart. This right here is an approximation, which is why I have the little squiggly lines. Somebody who doesn't know about math would look at the 8.6 and have a better understanding of what's going on, whereas the square root of 74 provides a lot more accuracy and is more exact to what the answer is. Kind of depending on who you would be talking to about this, you want to choose which kind of answer you'd want to present. All right. Now, the midpoint formula is the midpoint that we're looking for is going to be the point that is exactly between 2 points, okay? That is exactly between the 2 points, meaning that is the average between those points. Okay, it's the one that's exactly in the middle. Oh, yeah. Okay. Now, the formula for that we're going to do is we're going to take our x coordinates, so our x1 and our x2, and we're going to add them up and we're going to divide them by 2. And then we're going to do the same thing with our y, and that's going to give us a point that is exactly between our 2 points. It is halfway in between the 2 points. Now, you might recognize this formula as well. It's kind of, if this is a coordinate, we kind of have 2 separate formulas. This one to find the x coordinate, this one to find the y coordinate. This is actually just how we find an average, right? Add up 2 things, divide by 2, that's the average between them. If we find the average between our x coordinates, the average between our y coordinates, we're going to have the average for those 2 points, which is going to give us that point that's exactly in between. So if I'm given this point, okay, we have -3 and 8 and 5 and 14. What I would do is I'd start by adding my x's together. So I'll have -3 plus 5 divided by 2. And then I do the same thing with my y's. 8 plus 14 divided by 2. And then I'll go ahead, add and divide. So -3 plus 5 is 2, divided by 2 is going to be 1. 8 plus 14 is 22, divided by 2 is going to be 11. 111 would be the midpoint between these 2 points. It's going to be exactly halfway in between those 2 points. I want you guys to go ahead and try this one. You ladies and gentlemen, go ahead and try this one. Basically, just add up your x's, divide by 2, add up your y's, divide by 2, and that'll give you the midpoint. Go ahead and pause the video, try that, come back and check with me and see if you have the same thing I do. All right, ladies and gentlemen, and here I have my answer. I got 19 halves and 7 halves. Now, if you have that as a decimal, the decimals would be 9.5 and 3.5. That would also be the same answer. I tend to prefer to leave them as fractions. 1 is a little bit less work. 2, I can kind of avoid and give more exact answers, and I have to do some rounding depending on how large or how weird your fraction may be. Okay, and fractions are honestly easier to work with, as we'll see throughout the year. Okay, but basically I added 13 and 6, got 19 divided by 2, -7 and 14 added together, divided by 2, 19 halves, 7 halves. That would be the midpoint between those 2 points that we have there. All right, so now what we're going to do is we're going to talk about how to find if 2 lines are perpendicular to each other. But before we do that, we need to make sure that we identify what it means to be perpendicular. Now, you're probably used to talking about parallel and perpendicular lines and what those mean. Now, parallel means that your 2 lines, they go on forever and they never touch, meaning that their slopes are the same. With perpendicular, we're actually looking at something different. That means that your 2 lines come together and form a 90-degree angle. So what we need to do is we need to find, how do I find when these 2 lines are going to have a 90-degree angle? Well, I could pull out and measure it every single time, but I'd rather find an algebraic way, a mathematical way to do that, so I don't have to measure all the time when I look at those. And the thing that we're going to do is we're going to look for lines that have slopes that are what we call opposite reciprocals. Okay, so we're going to look for opposite reciprocals. Video, there's the word opposite reciprocals, meaning, and what that means when we talk about opposite reciprocals is that the sign of them is going to be different, and then the fraction is going to flip that we're looking for. The numerator and denominator are going to flip places, okay? So for example, one example of an opposite reciprocal would be 2, and then, oh, that's not how I want that to come out. We're going to write 2, and then negative 1/2. Those would be opposite reciprocals because this one's positive, this one's negative. We could think of 2 as 2 over 1, and if we flip those around, we'd get 1/2. So 2 and negative 1/2, those would be opposite reciprocals. So in order to figure this out, we have to then use the slope formula to figure out what the slopes of the lines are, and then we just compare them to see if they are opposite reciprocals, meaning the lines are perpendicular. In order to use the slope formula, just as a reminder, the slope formula is y2 minus y1 over x2 minus x1. So for example, in this problem right here, when I go to find the slope, I would say, all right, for my y's, it would be negative 2 minus 6, which would be negative 8. And then I do 2 minus 0, which would be 2, leaving me with negative 4 as my slope. With the second one, I do 5 minus 1, which would be 4, and then 8 minus 0, which would be 8, which would simplify to 1/2. These are not opposite reciprocals. Yes, they are opposites. One's positive, one's negative. However, if I flipped 4 around, 4 over 1, it would become 1/4, which is not 1/2. So they are not perpendicular. These two lines would not form a 90-degree angle. Here's the practice problem I want you guys to try. Basically, this is what you'll kind of see with this. You'll be given a triangle and they'll say, hey, does this make a right triangle? Well, some people would just look at it and go, well, it doesn't look like a right triangle, so it must not be one. But that can get a little tricky because when we turn triangles on their side, sometimes it's hard to tell if that's a right angle or not. Also, sometimes drawings are not drawn to scale, and you have to just go off the numbers they give you. And so you might look at it and say, well, it doesn't look like a right triangle, but mathematically, with how they intended it to be, it really is a right triangle, just not drawn very well, okay? Like when I draw with the mouse, it might not come out looking like one, but it might be supposed to be, all right? So the only way we can do that is by finding, all right, are there any slopes that are opposite reciprocals? So what we would need to do, find the slope between these lines. So I'd find the slope of this line, and this line, and see if any of them are opposite reciprocals. So basically, find the slope of AB, BC, and CA, and then check to see if any are opposite reciprocals to make a 90-degree angle. I'm going to give you guys a second. I'll pause the video. You go ahead and try that. Find those three slopes, and then we'll come back and check and compare them to see if they are perpendicular or not. All right, so maybe you went ahead and finished and you got your three slopes. If you look at our slopes, I got 1/2 for AB, I got -7 for BC, and I got -1 for CA. Now, I can see that of these three slopes, none of them are opposite reciprocals of each other, okay? I do have some opposite numbers, -1 and 1/2, -7, but they're not that reciprocal that I'm looking for where they're the numerator and denominator flipped around. So this triangle does not have any sides that are perpendicular, so therefore it is not a right triangle. We can put a big old X in it, not a right triangle, all right? Okay, so thank you for watching. Hopefully now you know a little bit better about how to figure out if lines are perpendicular, how to find that distance formula, and how to find the midpoint of 2 points.